So today we're going to be doing lesson 8-4, which is Quadratic Functions Applications, which is just a fancy way of saying we're going to be solving word problems using quadratic functions. Overall, the questions for these problems are the exact same. It's typically about a person standing on a hill or a person throwing a ball from a building or the ground. So all we're doing is we're basically going to be looking at the key information in the situation, so the numbers and the equation, and we're going to be using that information to answer questions about like, oh, the maximum height, the minimum height, when it's going to happen, all of that information, because it's actually quite straightforward and it all goes back to our axis of symmetry. So let's look at our first example today. Our first example is Alan is standing on a hill that is 80 feet high. That seems important, so I'm going to underline it. He throws a baseball upward with initial velocity, which is basically saying how fast something is moving, of 64 feet per second. The height of the ball, h of t, in terms of time t, since the ball was thrown, is h of t equals negative 16t squared plus 64t plus 80. So the first thing we're going to do is we're going to write down that this is our equation that we need to look at each time. The first question says, what is the maximum height of the ball? I'm giving you a heads up. Every time you want to find the maximum height, you want to look at your vertex. And the thing is, vertexes are x, comma, y. X is time, y is our height. So we want to find our vertex and find out the y value at our vertex. But here's the issue. To find your vertex, you need to know the axis of symmetry formula. The axis of symmetry formula is x equals negative b over 2a. So what I'm going to do is go to the side of my question and write down what my a value is, my b value, and my c value. A is equal to negative 16. B is equal to 64. And c is equal to 80. We simply make those substitutions. I get x equals negative parentheses 64 all over 2 times negative 16. And I type that into my calculator and I end up getting 2. That's telling me that x has to be equal to 2 at my axis of symmetry. So basically what I'm saying is that my vertex contains the point 2 comma y. To find out what y is, I go to my original equation and I just plug in 2. So I do h of 2 equals negative 16 times 2 squared plus 64 times 2 plus 80. So all I'm doing is basically everywhere I see a t, I plug in a 2. I type that into my calculator exactly as it's written, and I get 144. So basically, the maximum height of the ball is 144 feet. That is your final answer for that question. So whenever it says, what is the maximum height? The first thing you need to do is find your vertex. But to find your vertex, you need to find your axis of symmetry and then plug in that x value. Now, when did the ball reach its maximum height? Well, I just basically look at my vertex again. My vertex was 2 comma 144. Because this is my maximum height, and it takes 2 seconds. You're just looking at the x value of your vertex. At what time did the ball hit the ground? I'm just going to draw a little sketch. Your ball hits the ground around here. This is always going to be when y is equal to 0. So what I want you to do right now is go to Desmos.com. Students have asked me through email, how do I get to Desmos? I've told you multiple times over the course of the year that you need to download this as an app or bookmark it on your computer or phone. Go to Desmos right now and type in this equation, negative 16 t squared plus 64t plus 80. If you want, instead of writing t, you can type in x. Now on Desmos, you should see that it crosses your x-axis at a certain point. If you can't figure out by looking at it, what you can do is convert your equation to a table. You can do this all on Desmos. Ms. Townsend and I posted a link on how to convert things to a table. This occurs at 5 seconds. And then at what times does the ball reach 128 feet? You basically convert your equation to a table. And you should get at 1 second, and at 3 seconds. That is when the ball reaches 128 feet. So these two questions right here that we just did is a table question and a table question. You need to be familiar with how to look at the table of values on Desmos and a graphing calculator. So if I were you, what I would do is do the next problem by yourself as we transition. So basically you'll pause the screen or re-watch this clip right now. So we have a question called, a ball is thrown in the air with an initial upward velocity of 48 feet per second. This is done in height h in feet and t seconds, and it's given by the function h of t equals negative 16t squared plus 48t plus 4. The first thing we should do with these questions is always write down our a value, our b value, and our c value. In this question, a is equal to negative 16, b is equal to 48, and c is equal to 4. The first part of the question is asking me, what time does the projectile reach its maximum height? So whenever I deal with time, we want to look at our x value. So x value, because that is always time. Which means that we need to be looking at our vertex. So whenever we do this question, we simply just find our axis of symmetry. So remember, our axis of symmetry formula is x equals negative b over 2a. We substitute in our b value and our a value, and we get negative parenthesis 48 all over 2 times negative 16. We type that into our calculator, and we end up getting 1.5. So what that question is saying is, it'll take 1.5 seconds to reach my maximum height. Now what we want to do is we want to find out what the maximum height is. So again, we look at our vertex. And instead of looking at the x value this time, we look at our y value. Because this always tells us our height for these questions. So to find our height, we simply plug in a 1.5 for x. So everywhere I see a t, I put in 1.5. So I'm going to rewrite the equation. My equation was negative 16t squared plus 48t plus 4. So all I'm doing is everywhere I see a t, I'm going to substitute 1.5. So plug in 1.5 and I get negative 16 times 1.5 squared plus 48 times 1.5. And now I'm going to add a 4. After plugging this into my calculator, I end up getting 40. So my maximum height is 40 feet. What I would do if I were you is probably try to do the next question by yourself. You will need Desmos. You will need to know how to convert your graph to a table of values. You need to be able to type in negative 16x squared plus 48x plus 4 into Desmos if you don't have a graphing calculator. You need to look at the table of values feature so you can look to see when y is equal to 0. So when we do this type of question, we want to be able to look at, for our point, our roots. And our roots are basically where we cross the x-axis. Here's the thing. We don't care about the y value, we care about our x value, because it's when y is equal to 0. And we know our roots are basically going to look like this on our graph. So you need to make sure that as I said before, you have access to the table of values features on Desmos. So I'm just going to draw a sketch of what your roots look like. Your roots are always going to be where it hits the x-axis, where you hit the x-axis. And you just simply look at your table of values. So when I type this equation into my calculator, if you forget what the equation is, it's up top, the negative 16x squared plus 48x plus 4. I want you to go to Desmos right now and type it in. If you look at Desmos, it says it'll happen at 3.1 seconds. So at the time the projectile hits the ground, it will take 3.1 seconds. And that's your final answer. So if I were you, if you're stuck, rewatch the video just one more time. It's not a long one, and then try to do the independent practice questions. You will be having a quiz on Wednesday, so if you have any questions, please email myself or Ms. Townsend. Make sure you're looking at the notes and vice versa. All right, have a great day.